All right, so in this series of videos, we're going to talk primarily about domain and range. We're covering the content in section 3.2 of the textbook. Our objectives here are to find the domain of a function defined by an equation, but also by looking at graphs, to graph piecewise defined functions, but we're also going to talk about what we call our toolbox functions. So we're going to start off with a reminder about inequalities and interval notation. And so if we have the interval that is specified as x greater than 1, we would hopefully graph that. We would remember that that'll be an open circle at 1, and the greater than sign, why it's like curly there, I don't know. And we're going to go off to the right to the greater than side. In interval notation, we would be looking at 1 comma infinity because 1 is not included because this is a strict inequality. This next one, we're looking at going from -4 to 7. So -4 is less than or equal to x is less than 7. So -4 is included. Let's see, 1, 2, 3, 4. There's -4. So we're going to do a closed circle there, and then 7, we're going to find that's over here, and we're going to have all the x values in between. And of course, in interval notation, we're going to have our left endpoint of -4, our right endpoint of 7. The left endpoint gets a bracket because it includes -4. The right endpoint gets a parentheses because it does not include 7. And so we'll just, we can keep going on. Probably not going to do all of these because hopefully you should have your interval notation down pretty well. So let's see, x less than or equal to 4. We got to find 4. 1, 2, 3, 4. There we go. 4 is included because it's a less than or equal to. And we're going to go off to the left, the less than side. So that interval, reading from left to right, starts at -infinity, ends at 4. But 4 is included, so it gets a bracket. This next one is very much like the second one. We are going from -3, and that one is included, up to 5. 1, 2, 3, 4, 5. But that one is not included. So we are going just like that. So virtually identical, just different numbers. And then x greater than or equal to 0, of course, we will have 0 is included, and then the greater than side. So bracket 0, comma, infinity, parentheses. And really, I'm not going to do this next one. I'm just going to do the last one because the -1 to 8, it's the same. We already did 2 of those, right? So x not equal to 4 says that basically it's everything but 4. So we're going to put an open circle at 4, and all the numbers to the left and to the right are included. This is the one that's a little hard to write in inequality notation, which is why I like for you to graph it out first, so that when you're reading from left to right, you can say, okay, I've got -infinity up to 4, not including 4, and then my next interval or my next continuous line on the graph starts at 4, not including 4, and goes all the way out to infinity. So there's our quick review of inequality and interval notation. So we've talked a little bit about domain of a function, kind of informally. So in this class, and in basically most of your math classes, unless you become a math major and get all into crazy math, the domain of a function is the set of all real numbers that do not give a 0 in the denominator or cause a negative under an even root. All right, so that's what we're doing. We're throwing out anything that causes a divide by 0 error or a negative under the square root, which would cause a complex number. So for instance, nothing that would make us do 12 over 0, that's undefined. No negative square root of -4, because that would be equal to plus or minus 2i, and we don't like complex numbers in our equations. So none of that either. Okay. Let's see. We'll do a couple of examples, and then we'll do a break. Okay, so for this first function, we've got an equation. We've got 4x over x minus 5. And we're going to say if we plug in x equals 5, we will cause a divide by 0 problem, right? So we will cause us to divide by 0, right? So if we say f of 5 is equal to 4 times 5 over 5 minus 5, which of course is 20 over 0, which does not exist. So we do need to throw that out of the domain. So basically you're start with all real numbers. You're going to start with negative infinity to positive infinity, which if you want, you can always write as all real numbers if that is actually the domain. You can write this kind of weird R to represent all real numbers. But for this first one, we have to throw out 5. So in set notation, we're going to say the set of all x such that x is not equal to 5. In interval notation, we're going to just have to write negative infinity to 5, union 5 to infinity. Okay, so our next one, again, this is our other case. We don't want a negative under the square root. So the easiest thing to do here is to take what's under the radical and say, okay, I need 3x plus 4 to be greater than or equal to 0. Now, because if I plug in something that causes it to equal 0, that's okay, because the square root of 0 is 0. But as soon as I cross over into negative territory, I go imaginary, and we don't want that. So we're going to set this requirement that what is under the radical that must be greater than or equal to 0. We're just going to solve that. So we're going to have here that x is greater than or equal to negative 4/3. And we're just going to, so we're going to write that. So in set notation, we would have the set of x such that x is greater than or equal to negative 4/3. Or in interval notation, we would have bracket negative 4/3 to infinity. And that's a good place for a break.